All right, now we're going to look at I would say a more difficult example because it's going to be combining your properties of logarithms in order to solve. So what the equation is, it's log of 2x plus log of x minus 5 equals 2. Now what we need to do is we need to go ahead and use that product property. Since we see that they are adding and they both are log base 10, we don't necessarily need to write that, that's just there. We can go ahead and multiply it. So that gives us 2x times x minus 5 equals 2. And that is all with just one singular log. Now, what I'm going to do is I'm going to go ahead and write log and just multiply that out. So that's 2x squared minus 10x equals 2. And since this is a base 10 and we see that we're not going to get to equal x, we need to use a rewrite. So we're going to use our properties, basically, and we're going to go ahead and turn it into an exponential. And so that's 10 raised to the second power equals 2x squared minus 10x. Now, hopefully you should see that this is now a little bit easier. That's 10 squared, and we're going to subtract 100 because that's what 10 squared is. Hopefully you can catch on to that. 0 equals 2x squared minus 10x minus 100. And, you guys, we are going to be factoring again. But the first thing we can do is we can factor out a 2. That's going to be nice. X squared minus 5x minus 50. We're going to go ahead and factor. That all equals 0. What multiplies to be negative 50? That adds up to be negative 5. Well, x minus 10 and x plus 5. And we still have that 2 on the outside, which is not going to matter when we go ahead and solve. All right, I'm going to just move it over to this way for sake of room. And I've get that x equals 10 and x equals negative 5. So we are looking at two solutions, which if you look at our original form, we had 1. So we need to go ahead and figure out what one is going to be extraneous. Now you can go ahead and plug it in, and that's what we're going to do. So we should be able to see that if one works, the other one doesn't, similar to last unit. So let's go ahead and check. I'm going to check, let's see, I'll do 10 first. Log of 2 times 10 plus log of 10 minus 5 equals 2. That gives me log 20 plus log 5 equals 2. And then I get log 100 when I multiply 20 and 5 equals 2. Well, that's log base 10 of 100 equals 2, and that is definitely correct because 10 squared equals 100 when you do that rewrite. All right, so 10 is the answer, which means negative 5 is extraneous. I'm just going to go ahead and plug it in so I can show you why. So we've got log of 2 times negative 5 plus log of negative 5 minus 5 equals 2. It's cut off. All right, we've got log of negative 10 plus log of negative 10 equals 2. Now, right here, where we see that we have negative 10, it is 100% impossible to have a log of a negative number. So log of a negative doesn't exist because you cannot rewrite that to be any exponential to give yourself a negative. Remember we talked about that before. It turns into fractions, and that's when you raise it to a negative power, but we cannot get a negative 10. So that's proving why that x equals negative 5 cannot be the answer.